Imagine a single tunnel redefining travel between Scandinavia and Central Europe. The Fehmarnbelt Fixed Link is an ambitious 18-kilometer immersed tunnel project. This massive structure will soon become the world's longest underwater road and rail tunnel. Stretching 40 meters below sea level, it links Denmark and Germany directly.
Travel time is cut to just 7 minutes by train or 10 by car.
With a budget of $8.7 billion, this project is a true engineering marvel.
It promises faster, greener, and more reliable transportation across the Baltic Sea. It saves over 2 hours compared to traditional ferry crossings.
The tunnel is designed to handle modern transportation demands with ease.
Safety and sustainability are at the core of this massive construction effort.
Construction is racing towards completion by 2029. This project will transform the region's infrastructure for decades to come.
But how does such a colossal undertaking come to life beneath the waves? For years, travelers relied on ferries crossing the Fehmarnbelt. The ferry system was a known bottleneck for regional connectivity. Long queues and unpredictable weather often delayed travel.
The journey begins on the southern tip of Denmark.
This stretch of the Baltic Sea is a crucial connector for Europe.
Despite its importance, the ferry system was inefficient.
Time-intensive loading and unloading turned a quick passage into a chore. A fixed link became a pressing need to streamline this route. The idea of a tunnel has been discussed for decades.
Infrastructure projects began connecting nearby areas as early as the 60s.
But it was not until the late 90s that a direct connection gained traction.
Initial plans envisioned a massive bridge for road and rail. Feasibility studies suggested it was the most practical solution at the time. By the early 2000s, the project began to take shape.
A pivotal decision in 2010 changed everything.
By the early 2000s, the project began to take shape. The tunnel was deemed safer and more cost-effective. High winds, a challenge for bridges, would no longer be a concern.
Its low-profile design promised minimal disruption to the scenery. By 2011, the plan was officially approved. Groundwork soon began, and the project took form. It promises to revolutionize travel between these nations.
It is set to replace the ferry entirely.
Cutting travel time to 10 minutes by car.
This transformation
is only the beginning of its impact. The process begins with creating massive tunnel elements.
Each segment weighs an astonishing 73,000 tons. It starts at a state-of-the-art factory built for this project. Spanning 1 million square meters, the facility is massive.
Six production lines handle the creation of these elements.
Steel rebar is meticulously cut and welded here. High-strength concrete is poured with extraordinary precision.
Continuous monitoring ensures consistency and durability.
Climate-controlled halls regulate temperature and humidity.
Specialized plants produce massive amounts of concrete hourly. Waterproof bulkheads enable buoyancy for these segments.
They are moved into adjacent basins to await transport.
Tugboats tow the segments out to the sea.
A deep trench has been dredged across the seabed. GPS technology guides the precise placement of segments.
Specialized equipment creates the trench for the tunnel.
Excavated material is used to create new coastal areas. Giant rubber gaskets ensure watertight seals between segments.
A secondary membrane provides additional protection against water. Temporary steel braces stabilize the segments during installation.
Gravel layers secure the tunnel on the seabed. Onshore components like portals are also critical. These structures facilitate the transition from land to sea.
A lighting structure helps drivers adjust to the tunnel.
Road and rail upgrades ensure seamless connectivity. Safety is a cornerstone of the tunnel's design.
Emergency lanes and exits are provided every 100 meters.
The entire tunnel is monitored around the clock.
Surveillance systems ensure real-time management of incidents.
Passengers can be evacuated safely via designated exits. Air quality is another critical component. Ventilation systems maintain air quality in the tunnel.
Vehicle motion helps draw fresh air through the tubes.
Mechanical systems handle situations where traffic slows. The project demonstrates a strong commitment to sustainability.
It minimizes environmental impact throughout its life cycle.
New habitats for marine life are being created.
Coastal wetlands are being expanded. The tunnel will significantly reduce CO2 emissions.
Coordination is key for this massive effort. Weather conditions pose a constant risk to the project.
Managing a workforce of thousands adds complexity.
Logistical hurdles require careful oversight.
Despite these obstacles, the project makes steady progress.
The entire link is scheduled for completion in 2029. It will transform travel between Denmark and Germany.
The journey time is slashed significantly.
Cutting-edge technology meets a commitment to sustainability. This project sets a new benchmark for large-scale infrastructure. It promises to revolutionize transportation across Northern Europe. If you enjoyed this video, don't forget to like and subscribe.